Hey, what's going on, guys? This is your boy Network Prodigy, and what I want to do in this video is introduce you guys to a technology that's pretty popular when it comes to large WAN deployments, and that is DMVPN. Since DMVPN is so popular, you may come across certain positions that require you to know DMVPN because that particular company is deploying DMVPN for their wide area network. So it's a technology that you definitely want to make sure you know about for the real world. But even if you don't come across any positions that require DMVPN, or you're not in the current role that requires you to know DMVPN, you still want to know it because it does make up the CCNP Enterprise exam, so you may come across it. So without further ado, let's go ahead and let's talk about what is DMVPN. DMVPN at its core is a hub and spoke network. But what it does is it allows you to have a full mesh of GRE tunnels between all of the routers in your wide area network. And based on this full mesh of GRE tunnels, it allows traffic between spokes to flow directly between the spokes. So let's just kind of draw this out so you can understand exactly what I just said. So we said that DMVPN at its core is a hub and spoke network. So a hub and spoke network will look like this. You have router 1, you have router 2, you have router 3, and you have router 4. Okay, what's going to happen is 2 is going to connect to 1, 3 is going to connect to 1, and 4 is going to connect to 1. But these routers down here, 2, 3, and 4, are not going to connect to each other. So in a network design like this, router 1 would be considered your hub, 2, 3, and 4 would be considered your spokes. Now we mentioned that it allows you to have a full mesh of GRE tunnels. So when you first think about GRE tunnels, you think about the internet. So every single router is going to have a connection to the internet, and they're going to be able to form GRE tunnels between every other router. So how it will work is this. 2 is going to have a GRE tunnel going over to 1. 3 is going to have a GRE tunnel going over to 1. And 4 is going to have a GRE tunnel going over to 1. So at the present moment, each of the spokes only have one GRE tunnel, and that's the tunnel going back to router 1, who is the hub. Now in your typical hub and spoke design, since there's no interconnectivity between the spokes, so there's no tunnel going between 2 and 3, or there's no tunnel going between 2 and 4. If you wanted traffic to go between the spokes, traffic had to go through the hub. So the traffic between 2 and 3 would have to go in this direction, or the traffic between 3 and 4 would have to go in this direction, or the traffic between 2 and 4 would have to go in this direction. Everything would have to go between or go through the hub if you wanted to route traffic between the spokes. But with DMVPN, even though it does use a hub and spoke design, it allows the spokes to build these dynamic GRE tunnels between them. So at the current moment, the spokes only have GRE tunnels going back to the hub. But if at any point 2 needs to form a tunnel with 3, 2 can form that tunnel automatically. Just like 3 can form a tunnel automatically with 4, or 3 can form a tunnel automatically with 4, just like 2 can form a tunnel automatically with 4. The whole dynamic piece means that we as administrators, we don't have to come onto the routers and manually add the tunnels. So in a traditional GRE tunnel, if I wanted router 2 to have a tunnel to router 4, I would have to go onto router 2 and I would have to say interface tunnel 0. And then I would have to specify an IP address. I would then have to specify a tunnel source. I would then have to specify a tunnel destination, which the tunnel destination would be router 4. So if I was to do everything traditionally, I would have to go onto router 2 and I would have to manually configure the tunnel between 2 and 4. But with DMVPN, I don't have to do that. 2 and 4 can form the tunnel automatically. Really, when it comes down to DMVPN, the only tunnel that you have to manually configure is the tunnel going back to the hub. So you go on each of the spokes and you're going to manually configure this GRE tunnel going back to the hub, and the tunnels between the spokes is pretty much hands off. Everything is done dynamically. And this is why DMVPN is so popular in large WAN deployments, because here we have a small design where we only have one hub and 3 routers. But imagine a WAN deployment where you have one hub and 400 routers. All you have to do is configure each of the 400 spokes to connect back to the hub, which is a pretty simple configuration. But then you don't have to configure all the tunnels between the spokes. If the spokes ever need to forward traffic amongst themselves, they're going to be the ones building the tunnels. We don't have to really do anything. At the same time, if the tunnel is no longer needed, we don't have to destroy the tunnel. The spokes can do that on their own. See, if we were to do this manually, I would have to come onto router 2, for example, and I would have to say no interface tunnel 0. And what this will do is it will delete the tunnel going over to 4. But with DMVPN, I don't have to do this. 2 will just destroy the tunnel going to 4 when it's no longer needed. And that's why DMVPN is so popular. It allows your network to grow. It allows you to have this very large, wide area network. You still can accomplish the full mesh requirement without having to manually configure tunnels between all of your routers. All you have to do is manually configure the tunnel going back to the hub, and you let the spokes build tunnels on their own dynamically. So that's really the whole point behind DMVPN. Now, another thing that I want to point out is that when you go and you configure DMVPN and you configure the tunnel interfaces on the routers, the tunnel interfaces are going to be point to multipoint instead of your traditional point-to-point tunnel interfaces. So what I mean is this. If I wanted router 2, for example, to have a tunnel going over to router 4, I've already created interface tunnel 0. But this is going to be a point-to-point tunnel. So that means that there can only be one device on the other end of that tunnel, and it's router 4. If I wanted 2 to have a separate tunnel to 3, I would have to come on the router 2 and create a separate tunnel interface like interface tunnel 1. And then if I ever added another router in the future, I would have to create a separate tunnel interface like interface tunnel 2. Since all of these are point-to-point tunnel interfaces and there can only be one device on the other end, however many routers you have in your network, that's how many tunnel interfaces you're going to have to create if they're all point-to-point. But with DMVPN, you're dealing with point-to-multipoint. So what that means is I can come on the router 2 and I can create one tunnel interface like tunnel interface 10, and using tunnel interface 10, router 2 can form a GRE tunnel to router 1. At the same time, he can form a GRE tunnel to routers 3 and 4 because it's a point-to-multipoint. So with a point-to-multipoint, you can have unlimited number of destinations on the other end. It's not like a point-to-point where you can have only one destination on the other end. With point-to-multipoint, you can have multiple destinations on the other end. So with DMVPN, we're not dealing with point-to-point tunnel interfaces. We're dealing with point-to-multipoint tunnel interfaces. Now, let's go over some DMVPN terminology, because as we start getting into the design and how DMVPN works, all of this is going to come into play. So we have the non-broadcast multi-access or NBMA address. We just refer to this as the public IP. So remember, every router connects to the internet. They're all going to have public IPs. The public IP is going to be your NBMA address. You then have the next hop server, or the NHS. You have next hop resolution protocol, or NHRP. And then you have multipoint GRE, which we just talked about, the point to multipoint. That's what MGRE stands for, multipoint GRE. It just means that we're using point to multipoint tunnel interfaces and not point to point tunnel interfaces. So now let's kind of get into the DMVPN design. So each router is going to have one point to multipoint tunnel interface with a tunnel IP. So let's just come back here and let's just kind of start from scratch on a clear screen, and let's kind of draw this out. So we're going to have router 1. We're going to have router 2. We're going to have router 3. And we're going to have router 4. Okay, now we know that there's going to be some type of internet connectivity like right in here. So I'll just draw like a little cloud that'll represent the internet. So each router is going to connect to the internet kind of like this. And what we're going to do is we're going to configure a tunnel interface on each router. But remember, these are point to multipoint tunnel interfaces, so we only got to create one. So we create tunnel interface 0, for example, on router 1. On router 2, maybe it's tunnel interface 10. Okay, and we're going to use the same one on each router for documentation purposes and just to keep things simple. So every router is going to have a tunnel interface 10. And this is going to be for their DMVPN. Now each tunnel is also going to have an IP address. So router 1, maybe his tunnel IP is 10.10.10.1. It's a /24. Router 2, his is going to be 10.10.10.2/24. Router 3's is going to be 10.10.10.3/24. And router 1 or router 4 is going to be 10.10.4/24. Okay, so each router is going to have one multi-point tunnel interface with a tunnel IP. Each router is going to also have one public IP, which the public IP is going to be the non-broadcast multi-access or the NBMA address. So remember, each router is going to connect to the internet. So on this interface on router 1, connecting to the internet, he's going to have an IP of 11.11.11.11. And then on this interface on router 2, his is going to be 22.22.22.22. On router 3, that interface is going to be configured for 33.33.33.33. I know I kind of ran out of room. And then router 4, his is going to be 44.44.44.44. Okay, we're just going to keep everything simple. Okay, so each router is going to have a tunnel interface with a tunnel IP. They're each going to also have a public IP, which is the NBMA address. Now, in order to build a tunnel to another router, whether it's another spoke or the hub, you need both the tunnel IP and the NBMA address of that particular router. So we come back over to our diagram. If router 2, for example, wants to build a GRE tunnel over to the hub, who is 1, not only does he need the tunnel IP of router 1, he also needs the NBMA address or the public IP of router 1, and then he can build the tunnel over to router 1. Now, we're going to give the spokes the tunnel IP and the NBMA address of the hub when we do the configuration on the spokes, but we're only going to give them the tunnel IP and NBMA address of the hub. We're not going to give them the information for the other spokes, because we want the spokes to learn the tunnel IP and NBMA address of other spokes dynamically, meaning we want them to learn this information automatically without us having to give them anything. Just like with the hub, we could provide the hub with the tunnel IP and NBMA address of the spokes, but we want the hub to learn this information dynamically. So for example, we're going to log into router 2 and we're going to say, hey, router 2, the IP address or the tunnel IP and NBMA address of router 1, who is the hub, this is his tunnel IP, this is his NBMA address. We're going to log into all the spokes and give them this information manually. But we're not going to do that on the spokes. Instead, what we're going to do is configure the spoke, or we're not going to do that on the hub. What we're going to do instead is have the spokes give this information to the hub so he can learn it dynamically. So let's talk about how DMVPN really works. So the first step in the whole DMVPN process is the spokes must register with the DMVPN hub. This is going to be the NHS or the next hop server. So what you first got to do is build the GRE tunnel to the hub, and then you're going to give the hub your tunnel IP and NBMA address. So if we wanted router 2 to join the DMVPN network and build the tunnel over to 1, we would have to log into router 2 and say, hey, router 2, the tunnel IP for router 1 is 10.10.10.1, and his NBMA address is, and I put this in a different color, and his NBMA address, let's put it in blue. The NBMA address is 11.11.11.11. Okay, so this is the tunnel IP. This is the NBMA address. So router 2, we're giving him this information. So with this information, 2 can then build the tunnel over to 1. That's going to be the first step. The next step is that router 2 then has to give router 1 his tunnel IP and NBMA address. So when 2 builds the tunnel to 1, 2 is then going to say, okay, here is my tunnel IP, here is my NBMA address. So router 1 is having this little table that's being built saying, okay, 10.10.10.2 is mapped to 22.22.22.22. And we're going to configure the same thing on 3 and 4. We're going to give them this information so that they can have the tunnel IP and NBMA address of the hub. It's then their responsibility to build the tunnel to the hub and then provide the tunnel or provide the hub with their tunnel IP and NBMA address. So then router 1 can say, okay, I got 10.10.10.3 and his NBMA address is 33.33.33.33. And then I have 10.10.10.4. His is 44.44.44.44. So now every single spoke has built the tunnel to the hub based on the information that we've given them. They've given the hub their tunnel IP and NBMA address. Now the hub can build a tunnel back to them. So that's going to be the first step. Each spoke must build a tunnel to the hub and register with the hub. And when you register with the hub, you're giving the hub your tunnel IP and NBMA address. Now, in order to build a tunnel to a remote spoke, you have to have a destination that you're trying to get to, and the next hop for that destination must be the tunnel IP of the other spoke. So this is where your routing comes into place. So let's say that router 2 has a loopback. We'll just say loopback 0, and it's 2.2.2.2. 4 is going to have a loopback 0. It's 4.4.4.4. Now, if 2 is trying to send traffic to router 4's loopback, when he looks into his routing table, he needs to see that the next hop to get to router 4's loopback is router 4's tunnel IP. Just like if 4 is trying to get the 2's loopback, he needs to look into his routing table and see that the next hop is router 2's tunnel IP. Okay. Now remember though, if you want to build the tunnel to the spoke, you need 2 pieces of information. You need the tunnel IP and the NBMA address. When you look into your routing table, you're going to already have the tunnel IP, but then you need the NBMA address. So coming back over to our diagram, 2 already knows the tunnel IP of 4 based on the routing information. He saw that the next hop to get to 4's loopback was 4's tunnel IP. Now he needs router 4's NBMA address. Now we can provide router 2 with this information, but remember, we want the spokes to learn this information automatically. Now, if you don't have this information, what you're going to do is you're going to use NHRP or Next Hop Resolution Protocol in order to resolve the tunnel IP to an NBMA address. Think of this as Address Resolution Protocol or ARP. When you're trying to speak to a computer that's on the same LAN as you, you have the IP address, but you don't have the MAC address. So you're going to use ARP in order to learn the MAC address that is mapped to that IP. In DMVPN, this is what NHRP is used for. You're trying to learn the NBMA address that is mapped to a tunnel IP. What's going to happen is the spoke who is trying to do the resolution sends an NHRP request up to the hub. The hub is then going to respond back with the NBMA address to the spoke. It's going to be an NHRP reply. And this is why it's important that the spokes register with the hub. You're not just registering with the hub so the hub can build a tunnel back to you. You're also registering with the hub so other spokes can resolve for you. So we come back over to our screen here. 2 is trying to build the tunnel over to 4. So 2 is like, okay, I know what the tunnel IP is of router 4 is 10.10.10.4. But what is his NBMA address? Right now, I don't know. So what I'm going to do is I'm going to send an NHRP request, if I can spell request correctly, request. I'm going to send that up to router 1, who is my next hop server, who is my hub. And I'm going to say, hey, do you have a mapping for 10.10.10.4? And if router 4 has successfully registered with the hub, router 1 should be able to look at his table and say, yes, I do, is this. So router 1 is going to respond with the reply message back down to 2. So now router 2 says, okay, I know the tunnel IP, I know the NBMA address. Now I can go ahead and I can build a tunnel over to router 4. And router 4 is going to do the same thing. He's going to say, okay, I know what the tunnel IP is that I'm trying to talk to is 10.10.10.2. But what I also need is the NBMA address, which I don't have right now. So I'm going to send this NHRP request. I'm going to send this on up to the hub. He's going to say, yes, I have this information. It's right here. Let me go ahead and give you that. So then router 4 says, oh, okay, the NBMA address is this. So now with that information, 4 can automatically build the tunnel over to 2. And now they have a GRE tunnel between them. So now 2 can just use the tunnel to 4 to send traffic. 4 can just use the tunnel to 2 to send traffic. Now, if they ever stop sending traffic over this tunnel, what they're going to do is just simply delete it and it's no longer there. If they ever need to reestablish the tunnel, they will, but of course they still need this information. And if they don't have this information, they'll use NHRP in order to get that information. And that's pretty much how DMVPN works. Now, there are some phases of DMVPN that we'll go over in the next video. You got phase 1, phase 2, and phase 3. But I hope by watching this video, you have a better understanding of DMVPN and how the technology works. So if you like this video, be sure to like and subscribe, and stay tuned for the next video where I break down the 3 different phases of DMVPN.